of different options. And then you might use that habitual formation to guide your choices in the current context. And so maybe if you think potato chips, you've had a particularly good experience with potato chips in the past, you might be likely to choose potato chips in this decision between a potato chips and apple. On the other hand, this is often contrasted or compared with, you might think of more conscious deliberation in decision-making. This is often modeled in terms of model-based reinforcement learning, where you have an actual sort of model of the environment. You might take in specific information about the particular context you're in, the particular desires you have at the moment, your goals, et cetera, and that might inform your decision-making. So if you think maybe like you're on a diet, or maybe that you're just trying to eat more healthily, maybe you would choose the apple rather than potato chips, not because you think, historically speaking, that the apple has been more sort of valuable, or you've had a better experience than with the apple than the potato chips, but because given everything that you're currently interested in your current goals, that's actually a better decision. So it's sort of context-specific decision-making. So typically these are thought of as competing against one another. One way of thinking about this is just sort of a little formalization to give you a sense for how you might model, in the reinforcement learning sense, the way of making this decision of choosing the potato chips. The idea is that, well, for any given, in this case, sort of food choice that you might have, you've come to associate those with a kind of value, and then you're going to keep what we'll call a cached value. So it's a really simple representation, and the idea is you can have this sort of value estimation that you're updating over time as you experience each of these different things. So potato chips or pizza or fish or pasta or tacos or whatever. And the idea is then, well, for any item that's in you're presented with in your choice set, you're going to sort of automatically have access to the historical value of that. And here we're just calculating that in terms of the multiplication of the probability of seeing that item or seeing this context, and then the value of that action in this context. So you have both probability and value are going to inform what you choose. That's going to be compressed into a single value. And you're going to use that to just say, like, take the one with the highest value in the choice set. This is sort of supposed to be a very non-conscious process that you don't have much control over. It's just happening in the background, whether or not you like it or whether or not you think about it. On the other hand, if you think about the kind of model-based decisions, or the more model-based things, people often model these in terms of sort of stochastic decision process. So this is a little example of a drift diffusion model. And the basic idea here is that, like, for these complicated choices where there's a bunch of different features you might think about for apples, like maybe they're what they taste like, maybe what they look like, maybe what you've had recently, maybe whether or not you're on a diet, the health facts about these things, et cetera. You could pay attention to either of those, and you might go through this process of sort of simulating or gathering evidence about which of these two would be a better choice. And you might have in the drift diffusion model way of thinking about it, you might have sort of a boundary. And once you get enough evidence that one of these is better than the other, whichever one reaches the boundary first, that's the one that you're going to choose. So maybe you would choose, if you cross this threshold earlier for an apple, then you would choose the apple. Okay, so I think one thing that's interesting is that this way of thinking about decision maker and this kind of sort of way of studying decision making has also been true about how we study free will. So this is, obviously everyone here will know this quite well, this Libet experiment. The original interpretation of this was that maybe there was some early decision that was guiding the choice, and that was happening before you had any sort of conscious will, and we could detect that using, in this case, EEG. The idea, though, is that actually in recent discussions of this is stuff that Adina Roski has worked on amongst other people, was that you could think about a late decision model for the Libet experiment, which has to do with stochastic decision making. And the idea is this evidence that they provided with from the Libet kind of experiment and other ones, subsequently to that, including the stuff with fMRI, you can really think about as a stochastic decision making process. What you're doing is sort of, you're in the process of gathering evidence, or so the decision hasn't been made, but you're in the process of making that decision. What the EEG in this case is picking up on is that decision-making process. The actual decision process happens kind of late. So these late decision things can be modeled relatively well with stochastic decision-making. And so there's a way, I think, that what people have been doing when they're studying decision-making in terms of free will is really similar to what they've been doing in studying decision-making just quite generally in cognitive psychology. So I think one problem with this kind of paradigm is that it leaves us sort of ill-situated to find sort of causal evidence for conscious control in our decision-making. So on the one hand, if you think, it's really just this model-free stuff or this reinforcement learning stuff. If it's these automatic implicit processes that are causally efficacious for our decisions, then we don't really have much evidence for the role of conscious control in our decisions, because that's not the kind of process we would point to when we want to think about the role of free will in decision making. On the other hand, if it's these more deliberative model-based decisions, but those are really guided by stochastic decision processes, then that's not great either, in some ways, because we have this kind of randomness or stochasticity that's really driving a lot of the model-based decision making that we're doing. And so you might not think that's the best place to find evidence for the role of conscious control either, right? But I think one reason to think that we should still hold out hope is that I think this paradigm for studying decision making is pretty far from the real world decisions that we actually care about when we're talking about free will. So decisions like, you know, who to marry or which career to pursue or what to do for your summer vacation, or even just like, you know, what to have for your nice birthday dinner. Those are the kind of decisions where you might think we actually care about whether or not we have free will or can find evidence for sort of processes that allow for a role of conscious control. And this kind of paradigm isn't well suited for studying those kinds of things. So just consider, just to give you a sense for this, how different, like I think perfectly mundane real world decisions are. So here's one you can do. So if you could have anything to eat for dinner tonight, what would it be? I'm going to give you 20 seconds to make that decision. And as you're making this decision, I just want you to sort of pay attention to the decision-making process that's going on. So think not only about what you want, but also the various things that you're considering. Okay, so now that you've made that decision, you can kind of reflect on what not only just what you decided, and you guys can talk about that maybe during the break, and you can plan your dinner accordingly, but also just the other options that came to mind. And so what the interesting thing here, I think, is that, well, the set of options that came to mind probably have certain features, like they're probably generally good. But I think for me, this is a super interesting aspect of decision making, because you somehow managed to call to mind relatively good options without having figured out sort of whether or not they were good in the first place, right? You had to have some way of generating good options for dinner tonight without being able to sort of explicitly consider every single option, because there's an infinite number of options, sort of technically speaking, that you could have considered. So you couldn't have evaluated all of them and decided which one was best. What you had to do is come up with ones that are sort of plausibly good. So in a sort of work that I did with Fiery Cushman and Adam Morris, we started studying this kind of decision-making process. And I think this is the kind of thing that I'm going to build off of in the work that I've been doing with Reagan and Adina. So I wanted to sort of set up how we've been thinking about this decision-making process and why I think it's particularly interesting. Okay, so if you just get participants to do this kind of task, and then you just look at things like, well, how many options did they consider? Because we get them to decide and then tell us everything that they considered. What you can see is that they basically tend to consider somewhere between 3 and 4 options before making a decision in this kind of case. So that's their consideration set size or choice set size, or the number of options that they generated. And now if you, as I was pointing out, like those options aren't just random, right? You don't like just uniformly sample from all the possible things you could eat tonight and then decide which of those is best. You have some way of generating relatively good options. So in the way that we were thinking about it, given that you can't be doing any kind of explicit valuation of those options in terms of their value, you have to be relying on some kind of historical or cached value for generating those. So the idea would be of all the possible things you could have eaten, what you did is you came up with a few of them, a consideration set, and then out of those you chose. But if you think about how you determined which things came to mind, you had to use some kind of value estimation. And this is a place where we think reinforcement learning or model-free values could play a relatively good role, right? I mean, if you have sort of historically speaking, you've experienced these different things, then you could use that experience and the value of those things to call to mind whether those kinds of options to then choose between effortfully which of those would be best given the current context. Now, the kind of example that I just gave you, like of, think of what you would most want to have for dinner tonight. There's a problem in that this kind of cached context-free value is going to be highly correlated with what would actually be good to eat tonight, right? What you would really want if you want to show that it's sort of model-free or cached values that are driving which things to come to mind, we'd want to come up with a case in which what would be good in the current context, like for the decision you're facing right now is not that aligned with what, historically speaking, would have been good. So to do this, we came up with these other kinds of cases like this one. So here's a kind of funny one. So you just had dental surgery. Your doctor tells you that you cannot eat seeds, foods that are too moist, or chewy foods. You have $40 and you only have 40 minutes to cook. So what will you eat? And they give you 20 seconds to solve that problem. Okay, so now that you've solved that problem, I think you can again reflect on the kinds of options that you considered and think about what was driving the options that you considered. So this is a case in which probably the ideal food for you, generally speaking, wouldn't be the food that would be ideal in this particular situation where you've had dental surgery. You can't eat foods that are too moist or chewy or have seeds. So we gave participants problems like these instead, and then we asked them basically to make a decision and then list everything that they considered, all the options, and then we asked them two different questions about the options that they considered. So one question was, how good is this dish in general? So how much do you actually, generally speaking, like that food? And this was our estimate of a sort of model for your cached value that might have for that food, something that's not specific to this context. And then we asked them a question about the value of that dish in this specific decision context. So how good would this dish be to eat tonight? And now what we want to do is think about the role of these two different kinds of value in determining both which options come to mind and in determining which options they choose, given that something came to mind. And so I'm just going to give you a sense for what we find. So if you think about the probability of a food coming to mind, basically what we find is that if a food comes to mind, it's very likely that it has a high general value. That is, you generally think that thing's quite good. And if a food comes to mind, the probability that a food would come to mind that has a low general value is pretty low. That's much more sort of tightly related or predictive of what comes to mind than the context-specific value. That is this weird case in which you have $40 in these strange food restrictions. Okay, so that's what kind of value drives whether or not something comes to mind. And then we can separately ask the question like, well, what kind of value drives whether or not you choose something? So here I'm just plotting the probability that you would choose a food given that it came to mind. And you can think about the relationship for these two different kinds of values. And basically what you see is that what's incredibly predictive of choosing a value is just whether or not it's the highest value, context-specific value, whether or not in this particular situation is the best one. And that should be quite intuitive. But what's important here is that it seems like there are these two different kinds of valuation processes that are going on and driving these more open-ended decision processes. So one of them is this effortless sort of non-conscious learning process, which might determine what comes to mind. And then another one is this sort of effortful, more conscious evaluation of the options that do come to mind. So the basic idea, just to complete this model, and you don't have to worry about any of the formalism here, but it's basically the key idea is that you're going to have two different kinds of value that are going to determine this. One of them is going to be associated with cached values, which are going to be non-conscious and model-free. And another one is going to be associated with more conscious decision-making, the kind of thing that's been more closely studied in the lab and decision-making context with fixed choice sets. A kind of novel prediction that I think is fun and inspired the research that I've been doing with Adina and Reagan was these cases where you can compare a case where the options that come to mind should be sort of aligned with the current problem you're facing or really not aligned. So if you try to answer a question like, think of a food you would most like to have for dinner, that should be a relatively easy decision, which shouldn't require a lot of conscious deliberation, right? It should be kind of easy because the foods that are going to come to mind are going to be typically good, and that'll give you good options. But if I ask you a question like this, so think of a food you would least like to have for dinner. The prediction is, well, what's going to drive what comes to mind is going to be the value, historical value. So it's going to be like very relatively good foods are going to come to mind, and then you're going to choose amongst the relatively good foods that come to mind, what you would least like to have of those. Right? Probably, if you begin to think about it, there's certainly a food, the answer sort of immediately came to mind for the food you'd least like to have for dinner, you could probably pretty easily come up with something that'd be worse than that thing to have for dinner once you start trying. So you can now think about these two different things in terms of like the probability that this kind of decision context would lead to intrusions. So if I asked you to think of the best food, what's the probability that a sort of a low value food would come to mind? And if I asked you to think of the worst food or the one you'd least like to have for dinner, what's the probability that a high value intrusion would come to mind? And basically what we find in that prior work is that when you're trying to think of the food you'd least likely to have, you have these positive intrusions in the sense that you have these foods come to mind that aren't particularly good for the decision you're trying to make, but they're generally speaking high value. Okay, and that's sort of evidence for this, another piece of evidence for this general decision-making framework. Now I want to return to this question that we started with, which you might think, okay, if we started by thinking about the standard way of thinking about decision-making, which was that we have this model-free or non-conscious habit formation, and that sort of trades off or competes against this conscious deliberation in our decision-making. What I've shown is that, or what I've tried to argue is that, look, both of these things play a role in our decision-making. But maybe that you'd think just because both of these play a role, that doesn't actually help this question of where we might find sort of a place for conscious control and decision-making. Look, doesn't that just put us back kind of basically where we started? And so here's the basic thought. Look, if it's only automatic and implicit processes that are causally efficacious for decision-making, then again, we don't have much reason for hope. But if it's stochastic decision-making, again, and even if that is sort of more deliberative, but it's stochastic, again, that doesn't give us much hope. And so just to combine those two obviously is not going to solve the problem either. Like if neither of those were good, why would combining the two be any better for finding a role for conscious control and decision-making? But I think the key thing here is that the way we frame that past work left something really important out, and is the sort of insight that we had that led us to the current project. So if you go back to these results from this study where you're either thinking of food that you would most like to have for dinner or thinking of a food you would least like to have for dinner, the kind of result that I emphasize is here, where you have more intrusions, positive intrusions, when you're trying to think of the food you'd least like to have for dinner, and not many intrusions here. But that ignores like this enormous, much bigger effect, which is actually, if you're trying to think of the food that you would least like to have for dinner, then it looks like more than 60% of the foods that came to mind were actually not good foods, right? They're foods that generally you don't find to be valuable. And so it suggests that there actually is a way in which we're guiding this sort of implicit or non-conscious process of determining what comes to mind in the first place, right? You don't, if you're thinking of the best, trying to think of the best foods, very like, whatever it is, like less than 10% of the time to negative foods comes to mind. So there's a clear difference in how we're able to shift the kinds of options that we're generating in a way that sort of consciously or deliberately sensitive to the goals of the question that we're being asked. And so that's the place where we think, well, maybe we can actually try to begin to study that process. And that's going to provide us a way for thinking about studying the role of conscious control in real world decision-making, where part of the problem we have to solve is generating a set of options to choose between. So I think there's good reason to think that subjects in these prior studies have demonstrated a clear ability to guide their option generation or choice set construction in line with their conscious deliberative goals. Okay, so here's where the current study picks up. And what we're trying to do is study that particular part of the process of conscious control and option generation. So can we find evidence for the engagement of conscious control, sort of behaviorally or neurally, in option generation for more real world decision-making kinds of cases? And what we need to be able to do is be able to successfully manipulate whether or not you need conscious control in choice set generation. Okay, so here's the kind of design that we use. So participants responded to 10 different decision-making problems. These scenarios were drawn from a bank of 80 different ones that they could have answered. For each of those, they either received, for each 10, they either received the think of the best or think of the worst version of the scenario. And that was our way of manipulating whether or not they would need to engage conscious control and sort of guiding the options that were going to come to mind. So to give you a sense for what these problems look like or scenarios look like, they'd be something like this. So imagine you were trying to sell a house and you wanted to smell inviting. What candle would be the best to burn to make it smell inviting, or what candle would be the worst to burn to make it smell inviting? And you can think, I think intuitively you can feel that it might be sort of relatively easy to think of what candle might make it good and make it smell inviting. It's kind of funny and hard to think about what would make it worse, the worst candle to burn to make it smell inviting. To give you another example, imagine you need to pull a heavy cart. What would be the best or worst animal to pull that cart? Or here's another one. Imagine you're the boss of a small company and you need to get an appreciation gift for your employees. What would be the best or worst gift to give to your employees? Okay, so the study, we're using these kinds of scenarios, and the study took place over 3 different stages. So the first one was just this option generation and decision phase. So you could be given a problem like this. Imagine that your friend is going to cook you dinner tonight. What meal would you least want to have for dinner? And then we asked them after they answered that, how hard was it to think of a good answer to that question? And they rated the sort of subjective difficulty of that decision on a 1 to 5 scale. And then in addition, they listed all of the options that came to mind while making their decision. Okay, in the second phase or stage, what we did was we tried to measure these 2 different kinds of value. So what we did was we gave them back each of the options that they listed, that they had considered. And we asked them, in one case, a question about the cash value of that option. So we told them we wanted to make this judgment independent of the particular scenario that they were given. And instead just tell us, like, perfectly in general, how much you like or value or view as good each of the options that came to mind. And they were given a slider, a 1 to 100 slider, in which they were just saying how much they liked that or valued that thing in general. And they were given a second measure as well, which is context-specific value. So, like, specific to the particular scenario that you generated that option for, and we gave them back the scenario, we asked them how good was that option for that specific scenario. Again, they were using a 1 to 100 scale to indicate the context-specific value of that option that they considered. Okay, so a quick summary of the measures. So some of the measures we had were going to try to measure something like conscious control or engagement, so that we measured the response time, so how long it took them to solve these problems. Then we had this subjective difficulty rating, which was just how difficult was it to come up with a good answer to that question. We had a measure of cache value or model-free value, so how good is each option in general, and we had a measure of model-based or context-specific value, so how good is each option for this decision that you are currently facing. And now we can think about the predictions we would make in trying to study the role of conscious control in this kind of decision-making paradigm. So they're either asked to think of the best or think of the worst for the 10 problems that they saw. And then you can think about the options that came to mind. And sometimes they'd be generally good, and sometimes they'd be generally bad. So this is the sort of cached value or model-free value. In 2 of these cases, the options that come to mind are going to match the problem that you're facing. So if you think of generally bad options and you're thinking of the worst, that's going to match. And if you think of generally good options and you're asked to think of the best, that's going to match as well. The 2 key cases that we more care about are these cases of mismatched value. So sometimes if you're trying to think of the best and negative options come to mind, that will be what we call negative intrusion. And if you're trying to think of the worst and good options come to mind, there's going to be a positive intrusion. So in this study, what we would predict would be that we would find evidence for positive intrusions. Like when you're trying to think of the worst, positive things come to mind, sort of accidentally or in a not controlled way. And if you're trying to think of the best, that you don't get many negative intrusions. So that's one sort of prediction in this case. In addition, I think in thinking about the conscious control, the idea would be you're going to specifically have to exert conscious control to guide your decision-making in this case, where you're basically trying to think of the worst thing, because you're going to typically have positive intrusions, given the automatic processes that guide what comes to mind. The idea you need to exert some kind of conscious control in that particular case to shift the options that are coming to mind. And we could try to study that particular process in particular. Okay, so the hypotheses are that participants will experience many positive intrusions, but few negative intrusions. And that when participants experience intrusions, and we suspect that will be in cases where you're having positive intrusions, we're going to find indicators of conscious control engagement. So the decision should be perceived as more difficult, they should take longer, etc. Okay, so looking first at the evidence for this first hypothesis, here across all of the different scenarios we used are the number of intrusions that we find on sort of summing across participants, on average for each participant, or for that scenario. So if you're basically the sort of obvious effect here is that the blue bars are higher than the red bars, and that's really consistent across the different scenarios. what that means is you're more likely to have intrusions when you're thinking of the worst things. In that case, it would mean you're more likely to have positive intrusions than you are to have negative intrusions. You can, instead of looking at the data this way, you can just take the difference between the blue and red bars, meaning that basically what you find is that you're more likely to have positive intrusions than negative intrusions across all the different scenarios we looked at. There are a couple where we didn't find that, but the overwhelming majority of cases are ones where we did. The one, interestingly, just sort of anecdotally, the one where we find the biggest difference is that pull cart example, which I actually showed you, which is this one of, let's see if I can get back to it quickly. Imagine you need to pull a heavy cart. What would be the best or worst animal to pull the cart? So I think this shows, I think one thing that's nice is that these are pretty arbitrary cases where you have to having to generate options. It doesn't seem like, and they're varying a lot of different ways. Whether or not it's about what kind of food you want your friend to make you, or you're trying to get a gift for a friend, or you're trying to think of an animal to pull your cart, we kind of find this effect quite generally. Okay. So another important thing is that actually this wasn't, they were actually able to solve these problems about equally well. So the number of options that they were generating doesn't differ significantly between the two different kinds of conditions of thinking the best and thinking the worst, even though the number of intrusions does differ between the two groups. So if you just sort of collapse across all of the cases, basically here's the pattern that you find. If you're asked to think of the best things, what you find is that you typically think of good things and don't often think of bad things. But if you're asked to think of the worst, you have these positive intrusions. So you're often thinking of generally good things, even when you're supposed to be thinking of generally bad things. That being said, it's also clear that you are, the blue bars are differing from the red bars sort of systematically, right? Like people are directing the option generation process. They're thinking of generally bad things much more for think of the worst than for think of the best. So we can also think about whether or not in those cases, or that kind of the role, what I guess one way to say it is like, what is the relationship between our measures of sort of conscious effort and the options that come to mind? Okay. Right. So just to quickly summarize, participants experienced significantly more positive intrusions than negative intrusions. 37% of the options generated in the think of the worst conditions were positive intrusions, while only 9% of the options generated in the think of the best condition were negative intrusions. Okay, so now turning to the second question, when participants do experience intrusions, do we find indicators of conscious control engagement? So either subjective difficulty of the decision or longer decision times. Here's what those data look like. So if we're first going to look at the relationship between subjective decision difficulty on the y-axis and the number of intrusions. And it's basically what you find is that they are related, but specifically in the think of the worst case. So what you find is that the more the given participant for a given problem was having intrusions in the think of the worst case, the harder they found that problem to be. Right. So if you're asked to think of a meal that you would least like to have for dinner, the number of intrusions that you have where you're thinking of good foods rather than bad foods is significantly related to how difficult you think that decision problem is. It's also significantly related to decision time. So the number of intrusions is significantly rated. Sorry, the number of intrusions is significantly rated to how long it takes you to solve that problem. And that's, I think, importantly, was just driven by the think of the worst case. You don't actually find those relationships in the think of the best case. Okay, so we can also look at the relationship between the options, the value of the options that came to mind in decision difficulty. So here I'm again plotting decision difficulty, a subjective decision difficulty on the y-axis, and now just looking at the relationship between the value of the options. And so if you first look at the left-hand graph, it should be kind of intuitive, basically. Subjective, the more that you thought of options when you're trying to think of the best thing that were just good, that you would rate as being generally good, the easier that problem was subjectively rated to be. On the other hand, if you're in the think of the worst condition instead, the more that the options you thought of were having a sort of, were generally perceived as good, the harder you were finding that problem to be. So decisions became easier when options had a high cash value in the think of the best condition, but harder in the think of the worst condition. We actually didn't find a relationship here with the decision time. Okay, and then finally we can look at the relationship between context-specific value. So this is how good that option was for the particular, not in general, but for the particular problem that you're facing. And here the relationship flips in a way that should be intuitive and makes sense. So in both cases, for think of the best and think of the worst, the better the options you were generating for the particular problem you faced, the easier you thought the problem was, essentially. So if you're thinking of options that were good for a decision, it was easier. That's also not only true of subjective decision difficulty, but also true of how long it would take you to solve that problem. Okay, so to go back to our hypotheses for the second one, we predicted that participants, when they're experiencing intrusions, we're going to find indicators of conscious control engagement. Decisions perceived as more difficult are going to be perceived as more difficult when there are more intrusions, and that they're going to take longer. And that's exactly what we find for context free value, and that's not true for context-specific value. Okay, so looking forward, so that was study one, and we're just going to sketch what we're doing in the second part, which is trying to look at the neural processes that are involved in this conscious control and option generation during these kinds of problems. So I wish I could tell you that we have already analyzed all the data and I have beautiful results to show you, but we are at 38 of 40 participants, so we're quite close to finishing the data collection, but I'm not going to be able to show you the results yet. So instead, what I'm going to do is tell you about the setup for the experiment. And one of the things I would love to hear is predictions or ideas about the kind of analyses we could do. So the idea would be not only to look for behavioral evidence of conscious control, like subjective difficulty ratings or the amount of time it takes to solve a problem, but instead to look for neural evidence of conscious control during option generation. So the way that this study is set up is that in the first stage, participants are in the scanner and they're given the kinds of problems that we gave people before. So like, what meal would you least like to have for dinner if your friend is going to cook for you? They're then asked how hard it was to think of a good answer to that question. So this subjective difficulty rating, and then they're also listing all the options that came to mind. The key thing that we're going to analyze in terms of the neural evidence is this blue block. So we're going to look at what their brains are doing during the period where they're having to generate options or solve this problem. And we can compare cases like this one where it should be relatively hard and you're going to have to exert conscious control to ones where it should be easy, like what meal would you most want to have for dinner? So that's what happens during the scanner. They just go through a bunch of these problems like this. After the scanner, so just to make it clear how this is working, they're listing the options by speaking. So we're recording them during the scanner. We're then transcribing the options that they generated during speaking. And then outside of the scanner, we ask them a follow-up set of questions where we're measuring both the cached value, so how generally they think, how much they like or value or view as good each of the things that came to mind for each of the problems, and the context-specific value. We give them back the particular problem that they were answering when they generated that option, and then we said, for that specific scenario, how good of an option do you think that is? Doing this outside of the scanner allows us to clean up the data a little bit and allows us to not have people be on the scanner for quite as long. Okay, so we can then now, I think at the end, just think about what kind of predictions or what kind of role we think conscious control might play in option generation. And I think there are at least two different ways you might think the neural evidence is going to turn out. So one possibility is that the kind of brain areas we're going to see particularly activated in these cases where you're having to use conscious control to guide option generation, they're going to play a role of basically overriding automatic option generation. So you can think about it as a sort of like maybe kind of an actor criticky kind of way, but the idea is that there's going to be this option generation process where the options that have high value are going to automatically come to mind, regardless of whether or not they're good for the particular problem you're trying to solve. But you're going to have this process that's sort of watching over that, this conscious conscious control process that's going to monitor for mismatches between sort of the value that you think that option should have given its historical value and the value that it has in the current context. And then conscious control is basically going to reject that option and then guide you to continue to generate more. If I think to the extent that that hypothesis turns out to be right, we should see activation or increased activation in regions associated with conscious control, like the sort of the control network, classic control network, and that should be correlated with the number of intrusions that were coming to mind for that particular problem. So just to sort of fix the idea is like, look, if on a given problem, if what you're doing is you're generating a bunch of options that are intrusions, then that control process is really going to have to be active during that trial. And it's going to have to keep kicking out those options and keep forcing you to generate more and more, or sample more and more. Okay, so that's one way of thinking about how the data might come out. I think a different model would be that you could think about the role of conscious control as actually inhibiting that automatic process instead. So instead of what you're going to have happen is you're automatically generating these processes, and then you're rejecting them and searching for more. When you're exerting conscious control, you're actually going to have fewer intrusions rather than more intrusions. So I think these are two sort of, the neural evidence is nice here in a way because it's a way of distinguishing between these two sort of diametrically opposed ways of thinking about the role of conscious control. So the more that you're exerting conscious control, the fewer options are going to have happen. And you can think about that as basically like using conscious control to more effortfully guide the option generation process or inhibit the automatic process from the get-go. I think if that's right, you should probably see activation in control regions associated with decreased number of intrusions. And Reagan in particular has been interested in the inferior frontal gyrus, thinking that that might play a particular role if this second hypothesis is right. Okay, so I think what's cool about this, I think oftentimes, I'm a little bit skeptical of like, for fMRI project is, is the extra cost and effort worth the things you can find? I think this is a really nice example where using fMRI is going to allow us to do something that'd be hard to tell just from behavioral evidence. And there are these two different models for the role of conscious control in guiding option generation. And I think, one thing that's important for me throughout this process has been to look at these kinds of cases that are closer to the decision problems we care about when we often talk about free will. We can systematically manipulate whether or not you're going to require conscious control and look at the relationship between control regions and the number of intrusions that are coming to mind in these problems, and then use neuroimaging to figure out what the role of conscious control is. Okay, so the idea is that hopefully within the next month or two, we will have some results that I can share with you guys. But you'll have to stay tuned for those. All right, so I want to thank both Reagan and Dina for all their help. And Reagan here is really the one that did a lot of the hard work in this project. And Adina and I have been cheering her on from the sidelines often. And thank you guys too for listening.
Big round of applause for Jonathan Phillips. That was excellent. Questions? Thomas, as usual, first hand to be raised.
So, Jonathan, that was very interesting. I had a question about the difference. So what meal would you most or least like to eat? These are not symmetrical, right? Because if you ask me most, I'm just thinking at the top, where if you ask me least, you could be asking me, of all the meals that a person could cook, including my friend, which ones do I like the least? And there I'm having to imagine, who knows what, dog feces, human, there's all sorts of things I'd have to imagine. Or instead, is it the ones that he cooks that he knows I will plausibly like that I would like the least? So those are two, like, which of those already, I guess the worry is there's an ambiguity in the negative cases that is just missing in the positive cases. And it's not maybe the way that I feel like you're trying to explain it, right? Because like you haven't given me a way of like indexing the set that I'm supposed to be thinking about. So you leave it up to me. So already before I even make a decision, I've got to resolve an ambiguity that doesn't exist in the positive cases. That makes sense? I think that's going to be true in the animals case. Like for instance, which one is the least, which one is the worst one to pull the cart? Were you asking me to pick an animal? One, I don't even know how big the cart is. Crickets can't pull carts. Do I want crickets? They can't pull carts. So is it the animal that could pull the cart, but it's the one that's going to be the worst at it? But then I need to know how big the cart is. Whereas in the positive case, like I don't even have to think. A cart, ox, elephant, horse, right? Because you've already resolved the ambiguity, I think. I mean, so the question is whether or not there's just a hidden ambiguity in all these cases. Same thing with the candle. Are you asking me of all the candles I've smelled, which one I thought was the worst one? Or are you asking me of all the candles that could exist, which one do I think would be the worst? And something like that doesn't happen here again in the positive case. So I guess the worry is, I'm going to worry. Maybe it's how do you if one, if that seems plausible, and two, like, how would you then use it as part of the model you're developing? Yeah.
Yeah, I mean, I guess there are two kind of things to say. One is I definitely kind of intuitively get the thing that you're saying, and sometimes I think I can feel it in some cases, but I think when I think more carefully about it, it feels like there is a lot of ambiguity in the positive case too. Like if someone asks me what food, like what I most like to have for dinner, I'm like, well, do you mean like literally any food of like that, like no matter the amount of money, no matter like what, like including any restaurant I could eat at in London, or do I just kind of mean like, well, I don't know, like of the stuff that I would typically eat like here. I do think there's a lot of ambiguity in the positive cases as well. In terms of the more technical, like, do I think that that kind of, supposing that is a confound, do I think that that could explain the full set of results? I think probably not. And the reason is that in some of the experiments we did, they were much more tightly controlled, where we have a very fixed set of options. So you there are ones in which you have like 12 possible options, and they're perfect. Like, we make sure every participant remembers every single option at the end of it. And then we can show the same kind of pattern essentially with a small set where it's big enough that you still have to generate options, but it's small enough that we know that there's no ambiguity about the set of options we could be considering. So I don't think that could perfectly explain everything, but yeah, I intuitively get the distinction you're making too.
Questions, Peter. Okay. Guys, try to remember the microphones are directional, so try to speak orthogonally straight to that.
Hi, Jonathan. Peter here. Yeah, so I think it's important to, see this one role of consciousness is in telling the unconscious to generate options, and options are generated. But then often the role of consciousness is not simply to generate or elicit options, but to weigh among them and to play things out. Like, an example would be, oh, I'm hungry. That just popped into my head. Okay. Name me some restaurants unconscious, and then the elves in the basement generate some options. And then I say, well, that one's a little better, but it's farther away. And that one's, and then it pops into my head, oh my gosh, today is whatever, Ramadan. I shouldn't eat at all, right? And so there's a kind of aspect of consciousness that I think you're missing here, namely the comparison among options and the deliberation and weighing out, playing out. And then also the cyclical nature of this causation, where unconscious things generate conscious things, generate unconscious things, generate conscious things, until we evolve towards not the optimal solution, but an adequate solution. Yeah, I'd like to hear your thoughts on that.
Yeah, so I completely agree, I think, with both things. So in some ways in this second study, I've been leaving out a bit the role of conscious control or deliberation in selecting amongst things that came to mind. In prior work, we basically do try to account for that. We have a part of the model which says like, yeah, here's how you do the sort of effortful calculation of the things that came to mind, which one's best, and here's, we can do a good job of modeling a decision sort of conditional on what came to mind using that kind of conscious control process. I'm trying to think through more carefully, like whether or not what that would predict in the fMRI study, and it relates to the second part of your question, which is that in our oversimplified model of this decision-making process, we often model as a beautiful, well-formed set of options come to mind. There are 4, and then of those 4, you decide between them. And that's clearly, I think, not what happens for a lot of real-world decision-making, where we're generating an option, trying to figure out if it's good enough or whether or not we might be able to get a better option, thinking of another option. That kind of informs whether or not we sort of call it quits because we have an adequate thing, or we need to generate some more options. So there's this relationship between option generation and conscious evaluation or controlled evaluation of the options that are previously generated. I I guess what that would predict in terms of I'm just trying to think of like the control network, and during the scanner task, it would be, we'd see the more options that are generated, not the number of intrusions, but simply the more options that are generated, the more we should see conscious control regions engaged because of the evaluation of those options. So I think we could look for that kind of signature as well. Yeah, but I guess it's certainly not as neat as the model that we built. There is subsequent work we're doing in my lab on looking at that more iterative process and the way that the options that you have come to mind guide our subsequent option generation, and whether or not we decide to stop and like, accept tacos for dinner because it's a good enough solution for the problem we face. But yeah, in the fMRI study that we're almost done with, I think we could still detect that signature independent of the intrusion signature we're interested in.
Very, very often, so for some kinds of cases, only one option comes to mind, like, what is my mother's maiden name? Okay, well, that's, other cases will have options that are kind of apples and oranges, like this one might be better on that dimension, but that one's better on that dimension. And
Right.
then we have to weigh
Yeah.
that. It would be nice if you could think of a way to assess the complexity of the deliberation tree. So not just the options.
Right, yeah. The number of, the amount of incommensurability between the options should increase sort of like the effort of choosing between them.
Next question is Sam Murray.
So I think Peter maybe was picking up on one question I had. So two questions. So one was in terms of the asymmetry between thinking about best and the worst and the number of intrusions associated with it. I thought one case where that might not work is something like, think of the worst people. If I was trying to think of moral exemplars, I'd say, okay, think of the worst people, and then think of the best people. And those are cases where I think you wouldn't really get that asymmetry. And I was trying to think of why, and I wonder if it's because maybe I have separate representations for good people and bad people. So I sort of pulled those, maybe inform the process differently. But then the scenarios where you're talking about, it seems like I'm just drawing on one representation, right? So I have meals. My tendency is sort of start at the top when I'm deliberating about what to make for dinner. But then what you're doing in your case is sometimes you're telling me, no, actually go to the bottom of your list or bottom of that representation. So I wonder if you have any scenarios or cases where people might plausibly be drawing on two different representations as they're performing or constructing the option space. That was the first question. And then the second one was, it was also getting something with Peter, these are all sort of decisions within a category. So, select among meals, select among animals. But it seems like some decisions that we make are cross-categorical, for lack of a better term. So it is like, I might choose between getting married or going to grad school. But you just think that's not really I'm not even sure. So I'm not even sure how to extend your model to cover a decision like that. Maybe you think that's an inappropriate application of the model. So that was another question. Do you think that your model would extend to that kind of decision? Or do you think, no, that's also just a separate paradigm?
Yeah, for the first one, there's this paper that came out in Cognition a couple months ago from my group that was doing something a lot like what you're saying. So we're trying to show that value isn't the only thing that predicts what comes to mind. And I think that project was born out of sort of a dissatisfaction with thinking that somehow value is going to be the primary predictor of what comes to mind. So a good example of this kind of case is like if I asked you, like, think of a crime. Probably the crimes that come to mind aren't like are the low value ones, not the high value ones. You think of murder, you don't think of like underage drug use or something it's probably very like high value for the person doing it. And so, or cases where it seems like value doesn't have much of a role to play at all. So if I just say, like, I don't know, think of a zoo animal, which zoo animals come to mind? Why those ones? So, are the zoo animals come to mind somehow higher in value? It just doesn't make sense. So what we did in that work was show that value, while it is one thing that predicts what comes to mind, for lots of cases is not not even the primary or close to the primary feature, which is predictive for what comes to mind in different categories. we have that, that paper, it's called Locating What Comes to Mind in Empirically Derived Representational Spaces, gives a sort of a sketch of how you could think about which features are going to be predictive for what comes to mind for a given category. That being said, for these cases, and why I think that it makes sense to think of value for these cases, is these are decision-making contexts where the thing you're trying to do is come up with a good action. And I think in particular for action, which is what's primarily been studied, value is actually pretty predictive, or historical value is pretty predictive for what comes to mind. In for the second part of your question about, I don't know, things that don't seem to be in the same category or whatever. I mean, reinforcement learning frameworks are quite general, and it's not that hard to generalize to the kinds of cases you were thinking. So the way that they would treat that would be to say, you have a state that you're in, which is where you're making a decision. The things that you're considering are different actions to do at that state. Actions are quite general. So marrying someone and going to grad school are both actions. There's a sort of abstract level at which you could compare those two. So it shouldn't be a problem. I mean, as Peter was saying, it might be a hard, like in fact, empirically speaking, a hard comparison to make. Like, how would you compare the value of marrying somebody versus to the value of going to graduate school? I think those kinds of cases really point to a limitation in the reinforcement learning framework, which we've drawn on here, because all value is compressed into a single value, like a numerical value in a sense, right? And so it's that really multidimensional, seemingly incommensurable decision is supposed to be really trivially easy because you have two different values associated with these two different actions. So I think those kinds of cases are interesting and hard, but I mean, in principle, you could try to extend the framework, and you would just have to work out the details.
Right. Actually, as a host, I was trying, not every day I'm elegant. I was trying to be elegant at that time and let people ask before me, but this is my area of love and expertise. So I have like 5 or 6 questions, but yeah, I don't know if it's better to make them in a row, then you get the like general flavor of what I'm trying to touch upon. Or
I'll just answer the easy ones. Yeah.
Or start one by one. But for the first question is the following. It seems, of course, it'll be not very reasonable to be as demanding as to ask you that your model to cover everything, because a model is always a simplification, you know. So that would be absolutely unfair. But my first issue about your model is there is a hidden premise, some hidden premise there, that we have a generation, automatic generation of options, and the conscious control comes after to select, repress, inhibit, or there's no room for consciousness also generating possibilities. That's an important point. How much consciousness could contribute generating new possibilities? You know, of course, we have a more basic, more fundamental processing that generate more automatic possibilities, but there is also the possibility of your reasoning, your thinking, generating possibilities. So, what's your take on this issue?
Yeah, I mean, so in the cases that I've typically studied, the argument that it's not conscious option generation is like I don't have a good model for what that would even look like, because the standard way of thinking about conscious option generation is you would have some way of like enumerating that whole space of options and then deciding which ones you're going to consider. But like these are supposed to be cases where, you know, the set of options you would have to represent and decide which ones to consider in the first place would be really large, and it'd be seeming like weirdly inefficient to represent that whole space and evaluate that whole space to then decide whether or not to evaluate that space. Like there seems like there's some for option generation in particular, it seems like a case where, at least for these kinds of problems, it doesn't make sense to think about conscious option generation if you're thinking about like what food to eat for dinner. That being said, Clearly there are cases of like conscious option generation. The sort of paradigm cases that I would think about would be ones where even what kind of you don't have a lot of familiarity with the kinds of options that might be a solution to this problem. So like I don't know, like classic, riddles or whatever, where you're like, um, yeah, I don't know. I actually can't remember. It's like, the one where like, yeah, two people are found dead in a cabin on the side of a mountain, and there was snow on the mountain. There were no no tracks in and no tracks out. How could this have happened or whatever? And now you have to generate options or generate solutions to that kind of puzzle. I feel like that is a good case where the process feels very deliberative and the sort of hypotheses we're generating are consciously generated or consciously simulated, but none of them just pop into mind. But for the kinds of problems that we've been studying, like what to eat for dinner, it feels like what would it mean to have a role for conscious processes and generating options? I mean, it might be able to guide a generation process, but like the options just pop into mind. Like we don't have to do anything that we have epistemic access to, at least.
I mean, I was
in
just
terms
thinking of very, like, I would say, anecdotal examples. Like yesterday, I was considering 4 or 5 intervening variables to decide where to bring the speakers. So you're trying to consciously generate an option that satisfy a bunch of reasonable criteria. So in specific contexts, you can have a very rational generation of options based on the fulfillment of various criteria.
I guess what I would think was happening in that case.
And somehow we're talking about choosing a place to eat. It's not super differently categorically speaking.
Right. But like if you reflect on that process, what my model, like the kind of model we've been arguing for would suggest is that you have a set of criteria which you're trying to use to guide the options that come to mind. And then what's happening is there's this non-conscious process which is trying to be sensitive to that, which is generating options. And then you're consciously evaluating those options as they come to mind.
Right. Okay. Okay. So you see that there's like a process in which things are bubbling up, and the conscious control is more of a selective capacity. Okay?
Right.
My second
but in addition, you can guide. I mean, what I've been trying to show is you can guide option
yes,
generation.
exactly. Yeah. That was my concern. How is this the guiding process? If you have something else to say about that, that would be great. But my second question is going in the same direction of Sam's question. It is about incommensurability. Yeah, I mean, he gave an example, going to grad school or marrying. Here in Brazil, we'll have a terrible saying. I don't know if I buy the old Volkswagen Beetle or if I marry. It's because it's almost the same cost of the wedding ceremony and buying a Fusca, a old Beetle. I mean, I'm talking about those. I mean, in the case of your research, really focus on what Sam called cross-categorical decision-making. But, I mean, sometimes even among food courses, you can say you have some level of categorical conflict. It's absolutely different to have like a snack or a full plate. So, I mean, my issue is what kind of brain circuitry will be revealed with those cases that somehow propose to the decider more or less categorical conflict. For example, in the experiment I run with EEG, we had it was like gift selection. We have 3 categories and four stacks of prices. We see much more lightning in the anterior cingulate when you compare, for example, a box of chocolates to a bottle of wine, then 2 bottles of wine compared to each other, or 2 boxes of chocolate compared to each other, showing that there's more conflict when you have cross-categorical decision-making. So I don't know what kind of a take you can have from your research on that, or incommensurability of the stimuli representing some sort of cross-categorical representation. I don't know if you.
Yeah, that's a cool finding with the EEG. I mean, I think that's kind of what I would predict too, is the more sort of, yeah, you have to resolve some differences between the options. You should see more ACC activation. I mean, I guess I should say, like, in the particular study the paradigm we're using, it doesn't really, it's not going to be that many like incommensurable things. Like if you're
Yes.
thinking of foods to eat for dinner, I mean, it's foods versus foods.
Yeah.
The problems lend themselves to a single category in that way.
Yeah. Yeah.
But I mean, the other thing to say is like, say what you want about incommensurability, but we do make these trade-offs, right? We trade off money for people's lives. Like that's
Exactly,
a
yeah.
classic case of incommensurability. So we must have some mechanism for being able to compare those values, right? And we are, in fact, if money goes up a certain amount, people are willing to trade people's lives for it. So like, there is a way that calculation is being done. There are these frameworks on like sort of common currency or common value frameworks for different kinds of value. And yeah, I think I'd probably just have to draw on that research.
Nice. That's why I did these questions in a row, because this is my concern, is the idea of a common currency in the brain. How you solve incommensurability, because, I mean, how incommensurable they are in principle, it doesn't matter, because the brain is a problem solver, so he always finds a common currency. We seen some very interesting data from George Moll yesterday, showing that conflict between caritative donations has a lot of lightning in the frontal polar cortex. You just mentioned 5 minutes ago the inferior frontal gyres. Probably anterior cingulate is part of this network as well. We have a lot of meta-analysis showing VMPFC working as well on those kinds of trying to solve incommensurability problems. So I think in your case, it would make a lot of sense to go to an fMRI study, to try to reveal exactly those areas they are working with conflict monitoring and trying to create a common currency between the different stimuli. And what kind of educated guess you have now for the kind of network that will be revealed by the cases you're dealing with?
Yeah, I mean, the principle, like the primary analyses that we pre-registered are about like number of, like looking at the correlation between the number of intrusions on a given problem and control regions primarily, and also value-based, like the MPFC or whatever value-based regions for that. But I mean, I think what I liked about this study and why I was convinced it was worth doing was just because there are these two different models for whether or not you think you're overriding options that are generated or you're inhibiting the process of option generation in the first place. Those should look really different in terms of like the standard control networks and the number of intrusions you see. Exactly. So either you're working hard and therefore don't get bad options coming to mind, which I personally think that's the more exciting of the two hypotheses, or you can't really stop the automatic processes and you're getting, intrusions coming to mind, and then you're having to do conscious control to reject them essentially and keep searching.
Yeah, exactly. Well, that was pretty clear, and I agree that the first model was more exciting. I would say also more promising. Anyone other questions? Anyone else? So big round of applause for Jonathan Phillips. Thanks a lot. That was super clear. You conveyed a lot of content super fastly that give us room for a lot of debates. Sorry. No, you don't have to be sorry. I love people that speaks super fast like you and Thomas. So we now have a coffee break. It's already served, so you can just go to the cave. We are there. Thanks a lot, Jonathan, again. Big round of applause.
Enjoy the coffee. Yeah. Bye.
Bye-bye.